A tiny look at the wild, wild west of visual programming. In the world of visual programming, we have control panels with sockets. And we can connect those sockets with cables, which is unusually powerful and certainly self-documenting. There's always a high-level control panel for what you are working on, one that speaks with specific concepts related to what you are trying to achieve. But the stuff that plugs into the sockets of this high-level panel is ever more generic, and thus reusable, and thus consists of a small set of components that you can keep in mind that you are not going to be confused by. So if your high-level panel is a song, for example, then the panel will have a song title socket. And this is all very high-level, very specific to what you're trying to do. But to specify a title, you drop in a generic text panel and cable that or plug it in to the song title socket. Now, if you wanted to adjust the song's beats per minute or its speed, you would drop in a number panel and then wire that in. The farther you move away from the main goal, the more you are programming with reusable and generic components. In case of a book that you want AI to generate for you, you may have a book high-level panel, but also a chapter high-level panel, and they all plug in together. And both, of course, accept a bunch of text panels for chapter titles and AI prompts that get the book generated. Text panels also accept text functions, like join an array of text, or use this string or text template for all the named values that I plug into you. And before you ask, you make the high-level panels, though there is what can be called a standard library of primitives. For text processing, the language the visual programming language is written in will provide a lot. But to be nice, an additional library can be used. In JavaScript world, for example, that would be Lodash. So 100 useful little pluggable panels, and AI can help with setting up all the descriptions. For image and video processing, ImageMagick and FFmpeg would be used. It would be a standard library that generates shell scripts that then are ran by the operating system. And for audio, just to give a third example, Tone.js and web audio nodes would work out just fine. These are all very complicated programs that work in different ways. But under a visual programming model, here everything becomes a standard little box with sockets. A nice little control panel that you can plug stuff into. And of course, the act of connecting a socket is under the control of the programming language. It will only allow connecting what works, and in cases of more complex components, what makes sense. Under normal condition, a generic visual programming language won't let you connect a number to a text socket. But that can be expanded to include other types of data and even concepts. So here, Armed with such a standard library, you create your high-level panels that then become available in your toolbox as components that you can use in your own program. Or from another perspective, you can double-click a high-level panel to see what makes it tick, to upgrade it, to edit it, or expand it. But there is no standard way of doing anything. Every visual programming language is programmed different. Even the way these programs are executed is unique. Some programs need a start button. Others execute automatically each time something changes or a new connection is made. To visualize how these programs create stuff, just imagine the contents of the book we had the AI make getting printed below the visual programming interface. It's just formatted text. To work with videos and images, something quite similar occurs. The visual programming language creates a shell script, perhaps even with a really nice installer that can be downloaded as a zip file directly out of the web page. Then the new command can be installed on the operating system and used many times. In case of Tone.js, the audio generation system, it can be run in the browser. You can imagine a play song button appearing right below the user interface for the visual programming language. Code, or at least data file-based component connecting instructions, are still generated, but now you get to click play. With the aid of simple reactive programming setup, which would come packaged as standard components, it would be possible to adjust values live while the song is still being played. Cool stuff. Today, programmers still use directory trees and clunky third-party diagrams to map out their applications. But now, I think that will change, as visual programming can be made a lot more readable, computers are fast enough to show large graphs, and it is, after all, documentation and diagram-first programming, where it's easier for multiple collaborators to agree on things. I personally believe that the true power of visual programming is not just in the little boxes that are so friendly and inviting, but also in the fact that visual programs are self-documenting.